So we'll be starting with the first oxygen demand, that is biochemical oxygen demand, that is BOD. Biochemical oxygen demand, BOD. Okay, so write down the definition first. So BOD is a measure. BOD is measure of the quantity of oxygen required. Of the quantity of oxygen required for for oxidation of biodegradable organic matter. Biodegradable organic matter present in water. So see, this is the main difference between BOD and COD. Now we all know that this BOD, COD, these things, these are all oxygen demands. Okay, but this BOD specifically, it is only the oxygen demand required for the oxidation of what? Oxidation of only biodegradable organic matter. When we'll see COD, it will be the oxygen required for the oxidation of both biodegradable organic matter and non-biodegradable organic matter. Now, if the BOD is more, then what we can say? Then we can say that there is, or the waste is a strong waste, that is strong sewage. And if the BOD is less, we can say it is a weak sewage. So if we compare it with the nuisance, then we can write it as organic strength. First we'll write one relation, organic strength, it is directly proportional to BOD. So this we all know. If the BOD is more, that means organic strength or organic content is more. Now if we want to relate nuisance, so we have seen this, that is problem to human and environment. So this nuisance will be more if the BOD is more. So it is directly proportional to BOD. Now write down one note here. What should be the BOD of drinking water? So if you remember it, you can just write it in the comment. So BOD of drinking water. So what is the BOD of drinking water? It should be equal to 0. Okay. Now, so we'll write down some extra points about oxygen demand. So this oxygen demand of wastewater, it is exerted due to the oxygen demand of wastewater is caused by so it is caused by these two things. The first one is carbonaceous organic matter. Carbonaceous organic matter. Okay, so the main content here is carbon in the first one, and the second one is oxidizable nitrogen. So these are the two main, and the rest, the third category, we can call it as others, and in this others there are certain chemicals, or we can say chemical compounds. Okay, so these are not contributing much, but however these two, that is the first two, are majorly contributing for the oxygen demand of water. Now how to determine the BOD. So before that we will see exactly how or which of this organic matter is first oxidized when the oxygen is present in the water. So the first demand, you first write it down, you will understand it as we will go through the video. So the first demand occurs due to oxidation of organic matter, due to oxidation, oxidation of carbonaceous carbonaceous organic matter. Okay, so the first demand, it occurs due to oxidation of carbonaceous organic matter, and this is called as carbonaceous demand. This is called as carbonaceous demand, or it is also called as first stage demand. First stage demand. So initially the first oxygen is used for the oxidizing of the carbonaceous organic matter. Okay, once the oxidation of carbonaceous organic matter is completed, after this there is oxidation of ammonia. So that is nothing but oxidizable nitrogen. Oxidizable nitrogen. This demand this demand of oxygen it is called as nitrogenous demand. Nitrogenous demand. Okay, because it is the oxidation of nitrogen here, so it is called as nitrogenous demand. It is also called as final stage demand. Final stage demand. Now you should just identify this, or you should write one point here, that this first stage demand, that is oxidation of the carbonaceous organic matter, it is completed in the first 5 days. Okay, so in the first 5 days only it is completed, and this oxidation of nitrogenous demand, it starts after 5 days. Okay, it starts after 5 days. After 5 days. So if we draw a diagram here, if we draw a diagram, so it will get more clear. So here there are time in days, and here we are drawing BOD, and this BOD we are measuring in ppm, parts per million. Now in the initial stage the curve looks like this, and then it again goes like this. Now it is divided into two portions. So as we have discussed, it is divided into two portions. The initial portion is called it as first stage. Okay, and this first stage is also called as carbonaceous BOD, that is first stage BOD or carbonaceous BOD. And this is called as final stage or second stage, and it is called as nitrogenous BOD. So when we talk about the time period, so after 5 days or up to 5 days, the level of BOD that we are measuring, this BOD we will call it as, or this value we will call it as our BOD. Okay, so when we will be talking about BOD, we will be only talking about the first stage BOD, that is carbonaceous BOD, and not the nitrogenous BOD. So if we compare this now, so we can say that during the initial phase, that is from 1 2 3 4 up to 5 days, the BOD that is getting developed, it is due to the oxidation of carbonaceous matter only. So hence it is called as carbonaceous BOD. So these are the various points about the BOD theoretical concepts. Now we will be seeing how to find out the BOD in the lab. Okay, so determination of BOD. determination of BOD. So just pay attention properly. So first thing that we are going to do is we are going to take two vessels here. Okay, so first we will take two samples. The first sample is the, we'll denote it with VS, volume of sewage sample. Volume of sewage sample, it is present in here. So with this we will add, so we will write here VA, that is volume of aerated water. Volume of aerated water. So we are adding this concentrated sewage sample with certain amount of water. By addition of these two, we will get VD, that is volume of diluted sample. Volume of diluted sample. As we are adding water to it, the concentration of this sewage, it decreases and we are getting a diluted sample. So this is sewage, this is aerated water, and here we are getting the combined mix, that is volume of diluted sample. Now, so at this stage, when we get the volume of diluted sample, we will find out one important parameter here, that is the first one, we will find out the dissolved oxygen, that is dissolved oxygen DO. Okay, so at this stage we will find out the DO of the diluted sample, and this DO we will name it as DO initial, that is the content of dissolved oxygen which is present initially. Now this VD, or we can say this sample which we are getting here, this we are incubating. What we are doing after this, we are incubating the diluted sample at 20 degrees Celsius for 5 days. So these parameters are important, so you just remember this properly, the temperature and how many days. Now this 5 days, why we are taking, because we know up to 5 days the first carbonaceous BOD will be oxidized. So incubating the diluted sample at 20 degrees Celsius for 5 days, and after this, after incubating, the sample that we will get, will find out the DO of the sample after 5 days. So this sample is, we'll name this sample as sample after incubation. Sample after incubation. And at this stage we will find out the second parameter here. And what is that second parameter? DO final. So what we are doing is we are measuring the dissolved oxygen content at the initial stage, and we are measuring it after 5 days. So if we find out the difference between this DO content, that is difference between the oxygen content, then that will give us the biological oxygen demand. So the difference between the initial DO, and final DO will indicate the oxygen consumed by the oxygen consumed by the oxygen consumed by sewage sample in 5 days. Okay, so after this then we can calculate BOD, and this BOD is called as BOD 5. Okay, that is BOD after 5 days. So this is calculated by DO consumed multiplied by volume of diluted sample divided by volume of undiluted sample. Undiluted sample. Now here quickly we will see what is the diluted sample. See, this here, this is the volume of diluted sample VD. And how to calculate this? Vs plus Va. And this volume of original sample, this is only called it as, or we call it as volume of undiluted sample. Undiluted sample. So if we write it in formula wise, it will be this is diluted sample means Vd and this is Vs. Okay. Now this DO consumed, this we can write it as DO initial minus DO final. So DO consumed is equal to initial DO minus final DO. Now when we carry out this experiment, there are certain things that are constant, and that is the volume of the bottle in which we are taking these samples. So it is generally seen that this volume, that is Vd, this volume we are taking it as around 300 ml. Okay, so the total volume is, or the total volume should be 300 ml. So okay, there is one point here I have not written it. This ratio here, this ratio is called as dilution factor. Dilution factor. So first we'll write it down and then we'll write the remaining thing, because sometimes directly this dilution factor is given in problem. So if it is given, you directly multiply the DO consumed by dilution factor. So dilution factor is volume of diluted sample by volume of undiluted sample. Now this volume of diluted sample, as we have seen that sometimes in the question sometimes it is directly taken as 300 if it is not given, because the volume of BOD bottle volume, it is 300 ml. Okay, so 300 divided by the Vs in ml, and if the percentage dilution is given, then you can write it as 100 divided by percentage dilution. So with this now we can find out the dilution factor, DO consumed, and the BOD5. So one extra formula I will just write it down. This is the formula for calculating the DO initial, because see, there will be certain DO of this sample, initial undiluted sample, and that we will call it as, let's say, DO of sample. So this is the DO of sample. The DO of the aerated water, let's say this is called as DO of aerated water. So if we know this both DO, how to calculate the DO initial? So DO initial, it is calculated as DO of sample multiplied by volume of sample. So DO of sample into volume of sample plus DO of aerated water, DO of aerated water into volume of aerated water divided by the total volume, that is Vs plus Va. So with this formula you can find out the DO initial, then DO final you will get after the experiment, then this is the formula for dilution factor, and once you get all this you can use it and find out the value of the BOD after 5 days. So this is how you will calculate the value of BOD.